Welcome to part 2 of Homer's journey. This time Homer's going to make it to a couple sumo events before going to Motorama. So let's jump into Homer's upgrade for the first sumo event. So Homer's main upgrade for the next event is to go to hex shafts instead of keyed shafts. So basically this is the old shaft, this is the new shaft. You can just buy these right off of BaneBot's websites. The installation is very simple. You actually just pop off this little snap ring at the back here. This slides out, you pop the new one in, pop the ring back on, and it's just that simple. I have a little counterbore here. With the idea that I could put a washer on here and put a screw in if I needed to constrain this, but there's just so much friction in here that I didn't do it for the event and it didn't slide. I've printed these so that they're actually basically an interference fit at this point, so it's even less because it has to have enough force to actually shift like this pulley, which weighs like, like 20 grams or whatever off of it, and it's just there's way too much friction for that to be a concern right now. If it turns out to somehow happen, then I will switch over to something that will allow me to seal it to it, but for now I'm just going to have it friction fit on there. There's not that much room for it to even move around anyways. Like the worst case that happens is it starts rubbing against one of these sides, if that occurs. So not too big a concern there. Yeah, and it's still PLA for this. I just don't have enough time to get nylon stuff done for the next event because this guy's taking longer than expected. Just in case this saves anyone at any point, the P60S gearboxes, well, pretty similar to the P61S gearboxes, have one key difference, and that is that the shaft diameter is 3/8 on the old one. The internal shaft diameter is 3/8 on the old one, and is 9mm on the new ones, which means you cannot use the new hex shafts to upgrade them. Also, the mating interface here is different. It's a double D on the old ones, and it's a hex on this one. So yeah, if you have old P60S gearboxes, don't try to buy the hex shafts for them. I actually had 4 P61s and I bought 4 hex shafts, so it's okay, but I had to go rummaging and swap them around because I was treating them as identical otherwise. Now on to Homer's first sumo event, Anime North 2023. I was originally going to compete at this event with the Beetle as well, but electrical gremlins caused me to fail safety, and so I got to focus all my effort on Homer. The basic rules of sumo is it's a best of 3 where you try to knock your opponent off a 10-foot diameter platform. This event is still run as a double elimination tournament. Due to the more casual nature of it, sometimes we do more than 3 matches just to entertain the crowd while the next competitors are getting ready. Most of the robots competing in the 30-pound weight class are modified sportsmen or full combat robots, but there are a couple of unique entries as well. Due to having extra time, my first match is actually a grudge match against Crimson Snow. Unfortunately, the stream had issue recording audio for some of the fights, so instead you'll just get to listen to my voice. Homer's forks catch on the seam of the arena, which Crimson Snow capitalizes on, causing me to lose the first round. For the second round, I managed to psych out my opponent with a quick pullback and capitalize to take the round. And for round 3, I get an early advantage getting under my opponent, but noticing him breaking free, I managed to pull back just in time as he overcommits and sends himself off the platform. So Homer takes the match. I'm going to take this time to point out that I'm wearing the laziest Homer costume I possibly could be, blue jeans and a white t-shirt. My first tournament opponent is Hatsume Mikuevu, a robot that was finished probably 5 minutes before this fight. And if anyone's curious, no, it's not Charles Guan's robot. So unfortunately for my opponent, finishing the robot at 5 minutes to go just didn't give them enough time to get any real driving practice in. They also have the issue of their running flat forks, which without anything to leverage off of them just doesn't really work well against Homer. So Homer manages to dispatch of Hatsume Mikuevu without too much trouble and moves on to the next round. So now I come across Crimson Snow in the tournament, so this time it counts. Running into situations like this sometimes feel a little concerning because you're like, did winning the grudge match give away my best plays? Is he going to get me this time? But fortunately for me, Homer just manages to win the ground game on each simple engagement and can just take the victory from there. My next tournament match is against Whammo Can and Driveway Hero. They are 2 12-pound purpose-built sumo bots that have competed at another event, but compete here as a team. I actually had a bit of a strategy going in for this one. For the first round, I was going to target Whammo Can intentionally, and then try to recover the rest of the match from there. For the second round, my plan was to look like I was going to attack Whammo Can again, but then intentionally go for Driveway Hero first, and hopefully catch them off guard. And while that plan starts out well, I overcommit finishing off Whammo Can, and we have to go to round 3. For the third round, my plan is to nick the edge of the shield just off the pole, causing Homer to turn hard and trying to capitalize on the confusion that would create. I missed the pole, but I think the flange creates the same effect in the end. From there I want to focus on attacking near the center of the arena, but I end up banging into the pole, and it all falls apart from there. This next match is a grudge match against Cardcaptor Scuttlebot. Since this was a grudge match, I was more focused on trying out some techniques. The main thing I was looking to do was to try and get the face shield to clip the pole to do the hard turn. We also get audio back, so I can let someone else talk for some of this.
Underneath Scuttlebutt with those forks. Scuttlebutt shoved out of the arena. Go! Homer got around the outside. It looked like they were going to force Scuttlebutt out, but Scuttlebutt reacted really, really quickly and managed to shove Homer out. In a fight! Wow! Great driving by Homer there. 3, 2, 1, a fight. Two, one, go.
One thing that's starting to show up is the gearboxes seem to be binding every once in a while. It wasn't too impactful, so my plan at this time was to just continue using them for the rest of the tournament.
A straight shoving match. A big slam from Homer will give Homer the 4-1 decisive victory.
It's day 2 and I'm now ready for my first fight in the loser's bracket against Industrial Accident. Due to some timings, this is going to be one of those much more than 3 matches kind of fights.
Fight! So Homer the wooden robot maneuvering around Industrial Accident. Fight robots fight. Industrial Accident. Oh! One, go. Wow, really good driving by Homer, constructed by Dan. He is an excellent driver. I'm interested to see what Garrett can do with that interesting little pokey arm in front of his plow there. Fighting in 3, 2, 1, fight. Meaning I want to see that spike go into the wood. I really want to see the spike get impaled on Homer. Wow, good shove from Homer. Industrial Accident loses another one. And Dan is on point with his driving. And go! Really good driving by Industrial Accident. Around the side, it has Homer pinned up against the pole and shoves it out. Good job, Industrial Accident. Now go! Wow, it actually looked like Industrial Accident's wedge caught the edge of the center pole, like one of the little metal lip around the center pole, and that kind of stopped it in its tracks and gave Homer the chance to get around the side. Go! Wow. The clinical driving from the wooden robot is just on point. Go. I think Homer has a little speed advantage, but Industrial Accident has such a good plow on the front of it. Wow, that went into the wood. Did that make a hole on the front? That was crazy how hard that impact was. All right, you guys can fight as long as you want. There is a big gouge on the front of Homer. That's crazy. There is like a little puncture.
Over half an inch deep.
Okay, I got what I wanted. Fighting in 3, 2, 1, go. And go. Wow. Fight. And you can see those wedgelets hung up on the pole, kind of holding Homer in. Great driving by Garrett Campbell.
So this next match is a pretty exciting one. I'm up against Ralph, a pneumatic flipper who has done well both in sportsman and in sumo competitions. The thing that makes this most exciting is that if I win here, I'm guaranteed a trophy. I've never really been in this kind of spot before. In fact, normally I go 0-2 in most tournaments.
One, fight, robots, fight. Dance around the pole. The robots are locked. They're putting their drive frames against one another. And Homer. 3, 2, 1, fight. Being a little bit more reserved this time. They're going to use that pole, the great equalizer. Oh, and up in the air. Homer gets flipped up and out. 3, 2, 1, fight. That pole, we love that pole. Both robots doing a little bit of a ballet around it. Who has a better strategy? Who has the better response time? And it's Homer!
Well, that was an intense match. I managed to execute multiple maneuvers in a row with like a centimeter of clearance from the pole in order to cinch that victory. I'm still feeling the gearboxes bind a little bit when I drive around. I opt against changing them still. I can't remember exactly why. I think it was a combination of me not feeling like it'll be too much of a concern, and me also being afraid I'll mess something up while swapping them around. And now on to the second place match against Card Captor Scuttlebot.
3, 2, 1, go! Scuttlebot in pink has managed to lift Homer up onto its forks and leave it stuck. This should be an easy victory for Scuttlebot if it's careful.
Alright, to explain a few things. Homer normally has some limiters in place to keep the forks from going down as deep as they have been and getting Homer stuck on the floor, but they were made out of plastic and have all broken by this point. Second, Scuttlebot isn't aware that if you immobilize your opponent, that's the same as knocking them out of the arena, so he attempts to throw me out of the arena still. He makes an error while doing this, and I'm able to capitalize and take the round. I feel a little bad about taking advantage of this, but at the same time I couldn't tell if he was showboating, if he didn't understand the rules, or if the rules were different because the announcer had said something that kind of indicated he did have to throw me out. Either way, he's informed of the rules at this point and we continue onward.
3, 2, 1, fight! Homer's forks are half an inch away from the floor. Scuttlebot is dangling off the side. We might let the robots reset here. We are going to have the robots reset. Okay, matches pause. You guys go back to your starting spots. They are equally incapacitated. 3, 2, 1, go. And your winner is Homer. Third place will go to Scuttlebot. Homer moving on to the finals. You guys can fight again, I think, for fun. 3, 2, 1, go. Well, it's a good thing Homer didn't do that in the actual fights. 3, 2, 1, go. That was a good impact there. Both robots smashing each other. Wow, Homer takes that one again. Let's hear it for Scuttlebot and Homer.
Now on to the gold medal match, with the only people to have defeated me in this tournament so far, Whammo Can and Driveway Hero. Since this is double elimination and I'm coming up from losers, I'll need to defeat them in 2 sets in order to claim the prize. This is kind of crazy. I've gone from normally placing last in most tournaments to now potentially winning the whole thing. Have I learned from my mistakes? Do they have extra strategies? Let's find out.
3, 2, 1, fight! So Whammo Can, Driveway Hero are a team, a tandem. Homer has its work cut out for it. Just when it thinks it gets one, the other one will swoop around. Ammo Can and Driveway Hero trying to stack and shove as a team. Driveway Hero is currently underneath Homer, so Homer really can't maneuver. Its wheels are off the ground right now. Homer is out. Whammo Can, Driveway Hero take the first match. 3, 2, 1, fight. There goes Whammo Can. Your champions, Driveway Hero and Whammo Can. We're going to have these guys fight one more time just for fun. 3, 2, 1, fight. Ammo Can shot straight up and out of the arena, and now it's Driveway Hero who's going to try to get around the sides, maybe, of Homer. Garrett using that pole, the driver of Driveway Hero using the pole to shield up against a big ram from Homer. Garrett just about had it, went for an attempt at a shove out. Those metal forks doing slightly better getting underneath than that plastic shovel. This is a true driving tool here, folks. Reactions for both going to be keyed up. Driveway Hero hanging in there. Great driving. Insane reactions from Garrett Campbell, the driver of Driveway Hero. Homer, to his credit, isn't overreacting to any of these big attempts. Homer saves some face in that exhibition.
So one last grudge match to do before the award ceremony. This time, to keep things interesting, we're driving each other's robots. Unfortunately, I stand in front of the camera for most of the fights, so you'll just get to see the ones where you can at least mostly see what's going on.
Shoves Homer out of the arena. 3, 2, 1, go. If you wonder why we got a pole in the middle, it's for this reason, to force the robots to maneuver a little bit. Wow, great driving by Homer, and Scuttlebutt is out. Fight. Homer goes careening over the side.
So at the end of all this, Homer comes away with 8 wins and 2 losses and a silver trophy. When I first heard of Sumo many years ago, I didn't think much of it. But now having done it, it's actually a pretty great event to go to. Great driving practice, great drivetrain testing, and not having to fix your bot all the time is nice. Now on to some maintenance and a bunch of upgrades for Homer. First was a simple servicing of the gearboxes to stop them from binding up. I'm also switching the top and bottom plates from 1/2-inch plywood to 3/8 inch UHMW to improve ground clearance and durability as the plywood was splitting during combat. I'm also offsetting the bash plate's front holes to prevent splitting along the front frame. And many other things, so let's jump straight into it. One thing I'm trying with this new version of Homer is I have decided to get some stencils cut. So what happens is on Senkatsen's website, you have an option to get chipboard, 0.8 mils chipboard. I was curious if this would come nicely in the mail, but actually their shipping was pretty clever. What they did is there's actually 2 layers of their thick cardboard here, and this gets meshed inside, like underneath it. I think the opening's at the top. And it doesn't bend in shipping because all of the way they placed like the face shields were here, and then we had all the forks there. It prevented the package from bending in almost every way. And so the hope is that I will be able to just drop this here and punch these all out with a drill, and then probably still use a CNC machine to get those all nice, but maybe I'll run it with a jigsaw instead to save a bunch of time. So I got a stencil for the front plate to hopefully line up nicely the offset holes to make them drilling more easily. I think this is going to be a good idea. That's going to save me some time, and I realized that I could have done this as a multiple pieces of paper print or whatever, but this was just, just had to ship it off and have someone else do it, so I think it was worth it for the time save. So I found out yesterday that there's a sumo match coming up in just 2 weeks. So last night I got together the basis of the frame, and it's looking pretty solid. I still have to drill the holes at the back for the forks, but that's a minor thing. I'm working on the lid now, and so I have the template I have here cut from Senkatsen, and basically I'm just going around and using a center punch on all of the holes, and I'll just drill it with a hand drill and countersink it as I need to. For here, I was originally thinking I would use my my little CNC router there to cut these out, but it might be a little bit faster just to drill the corners out and then run a jigsaw along there, and just to save time. I have to do the top and the bottom plate still. I've made sure to cleverly mark the inside of the robot with what it is so that it's going to look pretty when it's done in theory. I also need to pocket out the middle part of the wheels just to be safe to clearance the belts. That's how I'm going through this, and we'll see how well it turns out. So I tried a few things to get these corner holes going. I'm drilling 3/4 inch. It was supposed to, I designed it for 20 mils, but 3/4 inch is available. So I tried with a spade bit with a small pilot hole here, with a large pilot hole here. And then I tried small pilot hole with a Forstner bit here, and that came out so much better. That's the way I'm going. It makes an interesting amount of messy plastic. So overall, the best way I found to do this is I was trying to use a set of calipers and measure out like half the distance, mark it with it like off of the edge, measure out half the distance, mark it with the edge, and then drill the pilot hole and go in. What works even better is if I just line up the Forstner bit with the thing here, push it down to mark the spot, then drill the pilot hole, and then run it through. And that works the best of them. So an interesting little development. Right before I went to go drill the first set of mounting holes for the fork brackets, I decided to check the lining up of it, and with the original brackets, because I'm just going to reuse them, and they don't line up, which was a little surprising. But I guess somewhere between what I actually modeled for Homer and what I built for the jig, this got changed slightly. I don't know if I just made a measurement error when building the jig or what. But yeah, it was good I checked this before I started drilling all of these holes, and it's also good to know that I actually can't use this. Unfortunately, this template was a waste, but the other templates actually worked out well for drilling those holes, so the template idea was still good. I just made a mistake. So I'm pulling up the guts of Homer 1.1 to push them over to 1.2, and the speed controller completely falls apart while I'm screwing it, or unscrewing it from it. And it looks like what happened is the screws that go into this aren't Loctited, and they just vibrated loose. Like there's one of them right there. I'll find the other one. Yeah, there's the other one right there. And they vibrated loose during all of those matches, but since it was clamped down through its mount holes, it was not an issue. So good from a redundant design point. So I was just inspecting my wheel hubs afterwards, and I found little bits of debris in here, little rocks or whatever, wood, stuff like that. And I should make a note to actually try and check these over every once in a while. Fortunately, they're designed to be as easy to service as possible, so it's realistic to do it even between every match. Not that I think I'd do it for Sumo, but for full combat, it'd probably be easy enough thing to just pop these off and take a quick look. All right, now to talk about Homer's brain transplant. So before he was run with an Arduino and an NRF24L01 receiver, one of these. There we go. And they no longer sell the SMD style ones, like the ones with the SMD style crystals on them anymore. They only sell ones that have the through hole crystals on them, or they sell these SMD ones. And these SMD ones are a little smaller, but basically what the idea is going to be is Homer is actually going to run a cluster for the sake of redundancy. So I'm going to run on one side, it'll be a regular nano with this SMD one. I field tested this style before, but I just wired this in for a couple of my 3-pounder robots, and it seems to work just as fine as any of the other NRF24L01 wireless receivers. And I've bench tested this, and this looks promising if it works out well. This is basically an Arduino Nano and the NRF chip together, which just saves a bunch of components. So what's going to happen is these boards are going to be both populated. The one that has this will just have less components on it because it doesn't need anything that goes in like this area. They will then be connected to each other, and they can communicate to see who is going to be in charge, who is going to send the signals to the speed controllers, which will deal with the motors. The circuitry is going to run independently, like the wiring is going to run independently for logic than it is for the power. So this will reduce any chance of noise getting in and wrecking the system. Not that I had trouble with that with Homer, except for power on. Sometimes it would glitch out, but it never had issue electronically in combat. Unless for some reason that's what killed my antenna during the match with Nautilus. Anyway, so the idea is going to be that there's going to be a new battery here that's going to be just in charge of running the logic. It's bigger than it needs to be for running an Arduino, but the idea is going to be that this is going to be actually require unscrewing to change. And so my hope is I'm just going to put a big enough battery to last a whole competition in here, and it'll run off, and I'll, like I say, not have to worry about it for the whole time. And then the main battery is still going to go here like it used to. I'm going to actually have 2 logic LEDs, and then there's going to be the main power LED, which I'll get to actually continue using from the original build. And the idea being that each of these they'll flash if they have no connection. It'll be solid on if it has a connection and is basically the one in control for the 2 cluster bits. And then it'll have one be dim if it has a connection, but is not in charge at the time. And so for this run, I'm going to manually control which machine is in charge. So I can run my field testing by basically run, because this is going to Sumo next. It's going to be run one match maybe on one system and then one match on the other system, and see if I get any kind of noticeable performance things or anything like that, to see if I should focus on making reproductions of these, all focusing on one system or another, if they're equivalent. In a longer term, hopefully I can make these automatically clustered, so they both just, like they'll just fail over and do whatever as they need to. But right now that they'll take charge, but I still control who I think should be the one doing it. So I'll have to manually compensate. If one of the boards fails and it's the one I'm telling controls to, I'm going to have to swap it, or I'm going to have to flick a switch on the controller that tells the other one, you can go now. I also forgot to mention that this is my first time using custom PCBs in a combat robot, or basically ever. All right, so I've got the components populated on the board now. Next thing to do is remove the brain. It's not rocket science, it's brain surgery. The main concern is like impacts, jostling loose components like this. And I'm not sure, it probably isn't an issue to have to worry about supporting the overhang of the component right here. But yeah, just wondering what I need to do to make sure these are secure enough. So for this antenna, it's only SMD secured on one line here. So I'm not sure if this will have like a leverage point here, if it's hit in a really weird way, or if it's just so much strong that it doesn't matter. So I still need to clean up some wiring, but Homer is ready to test his clustered setup. All right, so I'm having a few interesting problems here. One, it was working okay initially, at least the clustered talking back and forth, but I think the antenna broke on this one. I don't know what's caused it, but I'm moving on to just figuring out the other problem, which is when I tell it to go forwards or backwards, it's fine. When I tell it to go left or right, the wheels go the same way. Now, I tried running power to just one side of the wheels, or signal, sorry, to just one side of the wheels, or signal to just the other side of the wheels, and in both cases, they follow the one signal. So I popped out an oscilloscope and I checked, and this is the signal I'm sending, and this is the other pin, the other receiver's like signal wire, and it's getting a smaller amount of voltage on it, which with these they trigger at only 1 volt, so it's enough to for it to accept the signal. But this only happens when I apply power to the main drive. So when these actually are receiving power, for some reason, when I send a signal to, say, the left speed controller, it is also being echoed to the right one through some lower voltage situation. But I look at the wires, and it doesn't make sense, because I've actually blanked this microcontroller now. It's not doing anything. It's running literally the bare minimum sketch. So when I run power to this wire, like it runs to here, it's on the left side, and the other one that's attached to it is here, which is also on the left side. So there's no way, like they shouldn't be able to bridge their connection. Well, like I say, it couldn't be inducing a voltage really, I don't think, just because, like in the wires, because it doesn't show up at all if I run without power running to these speed controllers. But some power is there. Like the signal that goes here gets echoed slightly into here, but they're isolated from each other. I can't figure out how they're talking. Like we have diodes here just to have to prevent sending a signal from one microcontroller blowing the other microcontroller's pin. So there's no weird feedback loops I could see possibly happening here. I think I'm going to cut these wires next for the dummy speed controller and see if having that separated fixes it. So I've cut the wires out, and yep, they're still both talking to each other. All right, so this doesn't make sense to me yet, but I found I shorted one of the diodes out. I drive this, and it's working. It's working as expected. Only the left drive is getting signal. Yeah, and that's what I'm sending it to. So it looks like a diode is part of the problem. Another thing to note that made it weird is when I tied the grounds together from the high voltage battery and the low voltage battery, it stopped working. It was showing like it was getting no signal. When I was bench testing these speed controllers out, I did find if you try to check for continuity between like the high voltage side and the signal side, there's no continuity, except when you power it, the ground line and the signal line show continuity within them. And I don't know why that's the case, but I have to imagine all of this is like linked into the reason why. These speed controllers do work excellently otherwise, but like this wiring thing is weird to me. This seems like behavior I'm not expecting. All right, so I've replaced the diodes with just wire now, and yep, everything works. All right, so I'm putting together the assembly to do the weight check right now. I just am stopping to show over all the things I've done. So accessibility-wise, everything is quite easy to maintain on this robot. I've still managed to make it so that all 4 of these nuts to access the wheels come out easily. This battery can just slide out along here. It just reaches. I tidied up all of the main power wiring in here, so it looks a lot nicer now. The secondary board of the cluster is currently just doing nothing still. The plan is to make sure this all makes weight, get all the final mechanical parts done, and then if I still have time before the event, to start tinkering with this. Another addition to Homer was these little bump stops onto the forks. So basically the travel will be limited by the fork itself, so I don't need to worry about getting hung up on the ground with it. It also eliminates the need for having little bracket or bumpers on here. So it should keep the configuration simpler. So in the interest of not accidentally making these things pivot too far, I went on the conservative side that way, and as a result I need to grind down some of this material to make it all work out with the manufacturing imperfections of hand tools and wood. So basically I'm just running this on the belt grinder to get these pieces down so they all line flush. I've done a few of them already, so they're looking pretty good. And this way the travel will not go really any further than a mil past its scraping ground, and that should be useful if I get caught on a piece of wood or whatever. It won't cause the robot to pivot up on the fork. It'll just basically plane a piece of the wood off. And so that should prevent the robot from getting stuck as easily. So this is after doing one of the more extreme adjustments. So you can see it's a lot sharper material. I probably should have just taken an angle grinder and popped in a little dent right here. Maybe I'll do that for the following ones. But the belt grinder was just so easy that it was what I went for. All right, I've trimmed up all of the feet, so they only droop a little bit, or they all droop a little bit. Some of them droop a little more. Those ones are just ones that the alignment worked out okay on. When I was putting it together, I didn't mess it up enough. So just a little bit. So like I say, it should just, if I get caught on wood, it should only just take a fine layer of wood off, which is good. And yeah, everything is all super tidy in here. I really like how nice this has come together. I might get smaller screws before the event just to cut down this little bit of extra stuff that hangs out here and here and here and here. But that's just minor. I just got to go to Home Depot or something, pick some stuff up. But yeah, I really like how tidy all of this looks comparatively. It's a little bit of a mess in here. This could be a little cleaner, but it's also been, operated on. So good enough for this event. I'm still hopefully going to try and poke at this to see if I can get this system up and running, the secondary node in the cluster. But if I can't, I can at least still run with just the primary, and it should be fine. But like I say, the idea is to test for the clustered system now so that I know it's good for Motorama, because this event is more for testing out all of the changes I made to Homer for Motorama than it is about trying to win the Sumo event. I mean, Homer's not trying as hard as he can to win Sumo events, because if he did, he wouldn't have this silly shield on him. It'd be a different solution there. I'll do some drive tests tomorrow during the day. This should be a pretty fun event. So I for some reason have no footage of it, but I did manage to get the failover stuff working right before the event. At this point, Homer's pretty close to what's expected for Motorama, so this should be an excellent field test. The next event is a sumo-only outdoor event. It was held at Tesla's Electric City Festival, named after the inventor, not the car company, and as such, the coolest robot there is one that runs on gas. Unfortunately, a good portion of the stream data was lost, and what wasn't lost had the announcer's audio blown out. The main goal of this event is to test out Homer's new chassis and all of his other changes and see what works and what doesn't. My first match is up against Crimson Snow. My main strategy for this was basically just to try and get under him on the sides or the back, because obviously that's easier. He's clearly going to keep himself squared up to me as he can. After a few engagements, it's clear that even at the front, I will be able to get under his front plow. So as a result, it's just a matter of making sure I stay front on him when I can, and that he can't get to the side of me. It's still pretty easy for any robot to get to the side of Homer, so I just have to be cautious and leverage the pole as I need to when I make mistakes, and try to not overcommit to any given action. But I managed to dispatch him and move on to my next opponent. My next match is up against Industrial Accident. I make an initial aggressive play, but then I believe my gearbox seizes and he capitalizes on it. And we have a photo finish at the end. Let's get a look at that in slow motion and zoomed in. The sudden pivot he experiences is caused by my face shield digging into the ground, which is one of the first times it was a help and not a hindrance in Sumo. It's really hard to tell the depth without shadows, and I was on the other end of the arena, so couldn't tell myself, but it was ruled that his wheel touched the ground first and I get the point. Round 2 is a lot more straightforward. It's just an over-aggressive move by me, followed by a quick correction, and winning the ground game. I go for a battery swap and to check into all the internals of my robot, and do some basic tests. When I go to start it up again, the machine is just not working correctly. I quickly figure out that it's the cluster code that's not working correctly. For some reason, when a primary node tries to latch on, it just gets a failure because the secondary node is also trying to latch. So at this point, I just tell the primary node to always latch, and the secondary node I just blank. I tune Homer's turning so he'll turn sharper, which will hopefully also overcome the binding in the gearboxes as well as help me control better. My next match is against La Machine, and unfortunately that footage is lost. It's really unfortunate too because I lost that and I really wanted to review what I did wrong. So on to my next match against Scuttlebot. Scuttlebot is not being driven by its normal driver for this match. While the person driving is still talented, they don't actuate the lifter on Scuttlebot. So in a normal situation where we lock up together, Scuttlebot would have the advantage by lifting Homer, but since that doesn't occur, it results in a tie. This allows Homer to back off and try again, and we'll eventually get into a situation where I'll have a traction advantage and be able to take them out. I should also mention that this tournament is actually a round robin that will go into a single elimination top of 4 when we get near the end of the day. My next fight in the tournament is against Bort, Child of Honmer. Alright, so I guess we have a somewhat mirror matchup this time. Unfortunately, Bort's fork setup is a little better than Homer's. The extra length gives it a reach advantage which allows it to engage first. So at this point we lock up and I'm slightly winning the traction game most of the time, but Bort is gaining some ground at moments. I decide to try and maneuver where I'm going to try and pivot around to throw them off and see if I can gain the upper hand that way instead of just brute force them off the arena, but I make a mistake doing it and Bort capitalizes on it and takes the win. My next match is against Vega. Vega is running brushless drive and has sadly been having issues the whole day. This trend did not stop while facing Homer, and it was an easy win. This had Homer seeded 3rd when going into the final 4 single elimination bracket. My next match is against Ralph, but the footage for that was lost, and unfortunately I lost too. So on to the 3rd place match, which is a rematch against Bort. The main thing I have to do for this match is avoid getting in a head-on collision with Bort. Bort's longer forks will likely give it the upper hand in that situation. Fortunately, I managed to gain the upper hand at the right time and claim the win. Unfortunately for Bort, one of the drive pulleys blows during this action. So at this point 3rd place seems very likely. I just have to make sure I really don't choke on this last round. And with that, Homer does end up getting 3rd. So with that, I now need to worry about figuring out the gearbox issues, building a spare frame, and figuring out the cluster issues in order to prepare for Motorama. The first thing I looked into after the Sumo event was what was causing the issues with the cluster. Alright, so at the event I had a weird problem where the main node was getting a signal that it should be active from the secondary node. And when I check its data here, so these are just powered on, there's no signal right now, so you can see where is it over here? It's blinking because there's no signal. So if I check your in voltage, the grounds are tied, so I have ground reference here, and I'm checking my voltage on here, my what I call the rec in pin. Let's see if we can see it. Yeah, we can see it right there. So I check this, and yeah, I have 1 volt on here. Furthermore, like if we check rec out right now, I have about 0.75. That is because it is constantly disconnecting and reconnecting because it has no signal. So it drops off in case it's got a broken antenna or something like that, so that gives the other guy a chance to go in the ideal situation, but that's why it's registering some voltage. To clarify these pins, they control which node is in control of the cluster, and as such, the speed controllers. This is done to prevent both nodes from trying to talk to the speed controllers at the same time, which would not only send a bad signal, but would damage the Arduinos since the diodes had to be removed from the boards. So an Arduino will request control by pulling their rec-in pin high, and will know if the other node is in control by checking for a signal on rec-out. If they both request control at the same time, this race condition is detected and they will both give up control and try again later. If a node has a signal from the transmitter, it'll attempt to grab and hold control. If no signal is attempted, it'll check if the other node has control, and if it doesn't, attempt to grab it to signal the 2 speed controllers and then detach immediately afterwards as a fail-safe method. A neutral pulse to a speed controller is 1.5 milliseconds, and there's 2 speed controllers in this robot, so this is why you'll see me talking about the Arduino pulling high for 3 milliseconds next. So this microcontroller has gone bad. I'm going to now attach an oscilloscope to this to see if this is sending actually a pulse or if this is actually just somehow 1 volt. If it's just 1 volt, this microcontroller is completely fried because they're digital. But if it's some kind of pulse, that means it's in some kind of weird loop within its ROM that it's telling it to turn the signal on and off. Alright, so currently this is the signal pin from the primary node. So it's running for 3 milliseconds, which makes sense because it's sending a neutral signal to each of the speed controllers while holding it high. So basically it'll request control, it'll grab the signal, and it should be running at about 50 hertz. This is so it's rec in on this pin, which is rec out on this request for, control. If we check the other pin, we see on the other end is we have 1, 2, 3, 4, 5, 6. So slightly more than 3 millisecond duty cycle. So to summarize what I spend the next while figuring out, what I think happened is a piece of stranded wire that had been just left over from when I was cutting wires and soldering them together floated around the robot and eventually bridged the two pins together. And when an Arduino gets stray voltage on an output pin, it tends to wreck that pin. This then cascaded through the two set pairs of pins, causing them both to wreck at that spot. As I continue testing through these, the damage eventually takes out both microcontrollers, and I'm left having to replace both of them. But also during this, I decided to switch over to using a wireless signal instead of having a wired connection to make sure it works out. This reduces the point of failure at the slight cost of the cluster failover taking a tiny bit longer, but it's worth it considering everything. Alright, so to summarize what I've done, I've wired in everything except the speed controller signals on the secondary controller. That's just because I wanted to test everything before wiring it in case there's some kind of mistake. Both these guys are blinking right now because they don't have signal. This is solid on because it's the main power. That's the one that indicates like the drive power is on. So that's just on because this is on. It'll never do anything else unless power dies. It flows out. So anyways, I turn on my controller and select Homer. Homer is set to have the primary drive on. As you can see here, we've got a bright light on this one, which is the primary one. That light maps to this one. The down light maps to the microcontroller that's further down. So this one has control. If I flip it over, you'll get a half a second. What will happen is it'll go dim on both of them, and then the other one will go bright 1 second later. And yeah, these ones are blinking right now because to indicate that they have no signal. That's because there's no wires plugged in for this one. That'll get soldered in a moment. I'm just doing safety checking right now. So that's showing we're on the secondary. So in theory, if I move this around, it would be powering the secondary microcontroller. So if I flip it back, like I say, you'll get the same thing. I'll zoom out so you can see the speed controllers. They'll come back on in 1 second as well after the flick. See? So that goes, we got the solid white light there, or red light there, the solid bright light though, to indicate that it is receiving signal, and it is the one in control. So bright light means you're in control, dim light means you're not in control, and blinking means you have no control. Or blinking means you have no signal. So you can see here, it's driving and driving and driving. We can even switch in this case, and it fails over immediately to the other one. So we lose our signal, nothing bad happens. Flipping back, we'll get our 1 second delay, and boom, we're back here again. And then standard failsafe of shutting off the controller here. So that fails normally, and you get the blinking lights there to show that everything is working A-okay. So yeah, now I'm gonna wire up these, and hopefully everything goes okay. These get set to input when they're not in control, which is why there's all these huge timing delays on these things right now. And that should hopefully make sure that the voltage sent from one doesn't damage the other microcontroller, and vice versa when the other way around. All right, here we go, moment of truth. I've just wired everything together, and we are going to try and start it up. Turn on the controller, go. Okay, so we see here. That's using the first one. We're going to fail it over now. Fail back. Fail while driving. Yep, it's working. I built an entire spare frame for Homer, as there's a good chance he's going to need it. Unfortunately, the frame comes out warped, as wood will do that if you're not careful. I attempted to replace the side piece as I figured that's what was to blame, but it turns out it's actually the front piece, but I won't figure that out until after Motorama. I also decided to build up some long forks in the odd chance that I'll need the extra reach in a match. Alright, so I'm working on my long fork design here. This will be a foot long. I need to still cut like a slope up into here to match it up. It's just too late to be running the angle grinder now, but it's a minor detail. I've already test fitted it in here. This is the spare chassis, but it's good enough for this kind of test fit. And it looks like it'll fit nice. So yeah, dangles on the ground. Good that way. Good that way if it gets flipped upside down, actually. Let's just flip this upside down. That'll be, yeah, like that. got enough looseness in it that everything will go okay. And then, like I say, because there'll be a angled cut along here. This will then sit flush on the ground either way, but the upright way is the preferred way because that'll allow like a little corralling effect as well. Like it'll, if I catch on one fork and not the other, it'll tip them into the center of me. Then I'll have still a couple forks on here to just bop them up that little bit more for when they get impacted into the wall. So that's my hope in case I have to go up against another long fork kind of robot where I need to control them. And then of course I can pop these on the inside if it turns out that I'm fighting like a narrower bot and I want it to be here instead of here. But adjustments to be made at the moment and not to worry too much in advance about. I know my welding's terrible, but it just has to be good enough to last. It doesn't have to be pretty. And then grind this down to a point, which won't be hard to do because I have the belt sander there. And that's the plan. And then build another one for the other side and then one more spare. Well, it's not pretty, but I think it'll be basically equivalent and functional. Equivalently functional to something that is pretty. We get knocked upside down. Yeah. So it came out as I expected it would, which was nice. Yeah. So should just be able to ride the opponent up there, and if I'm upright, we get the slight bonus of this beam, which is here to add rigidity to this, but also gives a little like extra corralling force downwards towards the center of the bot to hopefully like off balance it just that little bit more. I think this came out good for the time I put into it. So a quick little change that's going on with Homer. I'm pulling out the secondary brain board and replacing it with this one. Basically, these extra components on here, after one of my events I did where I had a similar setup for one of my 3-pound bots, I just feel less confident without having to do a bunch of extra securing of things, and maybe they will hold, maybe they won't hold, that I'm just going to swap for this to keep it more durable in this case, just because I know this will be getting some huge hits, and just having a device where I don't need to worry about forces bending, like the voltage regulator, or like if this gets hit by a vert hit upside down, like pulling apart that chip, like pulling the antenna off, just to eliminate that concern. I think it could work if I maybe JB weld it down, and then like hot glue support some stuff, but it's just easier to just replace it with one. And then I still have this as a backup as well, so that's fine like that. And done. Looks nicer, cleaner, uniform like this. So coming up for this event, it looks like there are 3 axle bots registered now. The pipe bomb's here again, but we're also going to have Huge and Pepe Sylvia. And with that, Homer's regular faceplate has a chance of them rolling over it and just tearing the top of the robot apart. So with that, I went through a few iterations on ideas to try and stop it. Like I had simple basic faceplate to try and keep them back, and various like modifications of it. But when talking to some veterans, they were like, no, make sure your design is invertible because you're just one hit away from instantly losing. So I ended up going with something more of a sort of wedge plow on hinges here to hopefully be able to still, be aggressive with them, but not have the risk of, a single flip causing me to lose. So I've just welded the tabs for my anti-axle bot attachment that mounts to the chassis of the robot. I have the actual faceplate here that needs to be done, so I need to weld this, and it's pairing one over here. Unfortunately, my belt sander just broke. If I try to turn it on, don't work. So I need to figure out what happened to there, or it'll be a little more annoying to try and like sand down all of these sides of these to prep them for welding. It's a minor issue to deal with though. I could probably just mount it in a vise. Be fine with that. This is the first step. The welding went okay. I am not a good welder in any means, but it was okay enough. So the welding's looking okay so far. Okay for me, and okay for what this purpose is. So like these are in there pretty solid. The alignment I'm pretty happy with. There's only like this in theory should be touching when this is all the way over, but my lack of quality in welding shows that. But it's still it's very close still. The plan was to have two widths of space in here, and actually have a little bit more. Part of it was because these are a little further apart than originally planned because of the little bit of clearance spacing in there. It goes in here, it's loose enough. And so the idea is going to be that there's going to be bolts in here. There's going to be little rubber bits as well that work as little stoppers to prevent this from going too far. And this will simply bolt onto the front of this here instead. So I'll just take that shield off and replace it with this if I need to. It's just 5 bolts plus, these bits, these couple, well, 3 bolts on each side here. And it should be a nice swap to make this ready to fight some axle bots. Like I said, I'm still not sure if I would use this on Pepe, but this would be what I would try if I had to fight Huge or Pipe Bomb. So this is Homer with its new modifications installed. I can't run both these at the same time. Basically, to run this plow, I have to take off all the forks at the back. But yeah, I have the shield pivoted. It has limited range based off of these little blocks here. I'm going to try and limit the range a little more by printing a little bit thicker of a spacer there. And then if I need to use long forks in a situation, this is it here. So now basically I can test if driving around with both these attachments, if either of them cause a problem. But I don't expect they will. Homer is ready for Motorama 2024. It is Thursday. We're leaving tomorrow morning. So to go over all of Homer's upgrades. So Homer's now at version 1.3. Homer competed last time at version 1.0. So the upgrade to 1.1 was the switch of the pulleys in there. Before they were keyed. And now they are hex shaft. So like the gearbox was upgraded to have a hex shaft on it, and then the pulleys were modified to do that. To go to Homer 1.2, the top and bottom lids were switched to UHMW. The faceplates bolts are offset so they don't create a single line across in case there's a split again. For 1.2, Homer tried running its first version of its cluster system. That is the microcontrollers work together, so like if one fails, the other can take over. The bolts all around are number 10s instead of number 8s now, and there's less of them, so it balances out that way. And I think that's it. So for 1.3, the cluster system was revamped again. Due to the way the communication works with each other, they both had a separate signal wire to claim who's in control. And I don't know what happened. They shorted against each other, whatever. They blew each other up as a result. So it's different now. They both run wireless, and just the controller tells them who's in charge. So it's a simple failover, and I control the failover. The battery pack has been upgraded to be a TPU one, and then it has a TPU battery restraint in there, like the little belt that holds it in instead of you being electrical tape. There is also additional front plates. There is a anti-axle bot faceplate over there. And then I have a longer fork option here. Longer fork attachment here. In case I need to fight against someone who's specifically running the ground game. Like if I come across another Ava again, it's difficult to win with the current forks. So just having a different setup for when that comes up. It would also be good if I had to say fight something like Megatron, but I don't believe he's at Motorama this time around. So I think that's all of Homer's upgrades for this round. Hopefully it turns out well. The pulleys are still PLA, but I just finished printing nylon ones there, so I'll fall back to those if the PLA ones explode, but in the Sumo events they were fine, and I think they really only exploded before because it was a keyed shaft, so it was a lot of force into a single point of PLA. So yeah, that's that. So Homer passes Homer on the way to Motorama and gets a lovely surprise when he gets there. A friend has designed and made a vinyl sticker for Homer, so we slap that lovely thing on there and get ready for our first round. And that first round is against Lil Rip, the 30-pound version of the BattleBot Ripperoni. So let's see how that goes. I'm once again going for the strategy of taking my opponent head on and hoping they stumble and I can capitalize on it.
In the blue square, Homer, are you ready?
Blue square, ready.
You're ready to go. Let's put 3 minutes on the clock.
3, 2, 1.
Right away, Homer not messing around. The Little Rip taking a side shot into that wood frame. They're going to hope to keep that steel.
Shortly into this match, one of my drive sides starts showing issues. This was likely from the side hit and will quickly worsen as the fight continues.
Starting to point the right end in, the Little Rip hoping to kind of turn around and get more of a bite in. Now even on this little design, Little Rip also has that counter-rotating mass in the back to help try and cancel out some of the massive gyroscopic forces that big disc delivers. Little Rip being so quiet, but oh, there's a nice shatter of wood. Little Rip doing his normal little song and dance after taking a quick careening hit.
2 minutes remaining.
It's turning a little more of a strategic affair now that Homer has had a couple licks. They want to keep that steel plow right in check. A Little Rip there testing the integrity of our arena bumpers. Another glancing shot onto the plow on the front of Homer. Not looking like it's doing much, which means the plow is doing its job. A lot of the steel being used now these days for armor is what we call AR-500, is a wear-resistant steel plate, capable of holding up to quite a bit of abuse. You can tell the aggression has turned to a more passive approach now as both teams have taken a couple hits. Little Rip bouncing away. Just taking her time, knowing Homer is a little wounded, hoping to get in for that one kill shot needed on the end. The Little Rip is spinning a little bit slower now, probably more of a conservative game, not to impart more damage on themselves too. Because you have to think for every big reaction, there's a opposite reaction that goes back into the frame of the robot too. 30 seconds left to go in this fight. We may finally get to a judge's decision. Once again, Little Rip, a couple more hits being delivered onto Homer. Homer still trying to keep that arm around there, hopefully trying to break Little Rip in the process. But it sounds like they'll make it to the 3 minutes. All right, we got smells delicious, and your judges agree. The winner, the red square, Little Rip.
The problem, or what happened with Homer, is we took the side impact, this gear shattered. So I'm going to replace these with nylon ones and give that a go. We took damage on the sides, which is expected, which is why the spare parts of it, and the LED light wire ground broke out. So we'll fix the sides, we'll swap the pulleys, and then hopefully we're good. Oh, also the motors came a little loose during that. So we'll see if we can tighten them up. And this cracked here, but it's still good enough, I'm sure. Did this crack too? Yeah, these cracked as well. These will probably need to be something better than just PLA as well. So the joy of PLA might be going away on this spot. Although these wheels have all been holding up fine here. Still, that'd be an easy improvement for the next one. Just print a nylon. My opponent Cemetery Wind and I barely get our robots together in time for our next match. In fact, Homer's front frame rail still needs to be replaced. I equip Homer with the long forks and the flat ends. This is to hopefully give me more control while fighting him and keep him from clipping the tops of my wheels.
3, 2, 1.
Once again, losers bracket fight here. Hopefully you see that blade on Cemetery Wind spin up. Well, he did sell the blade between the top plate and the frame of Homer. So that's a success. Right now, Homer's starting to fork his opposition. Forks, I would say, are the standing cup of defense mechanisms. I'm using my trends appropriately here. Everybody uses them. They're kind of a little wacky. Overhyped, but right now, Homer switching to the plow and just starting to slam Cemetery Wind into submission. Why won't you stop moving? Stop moving! Now!
At this point, Cemetery Wind's driver comes over to me and asks if I can try and free him out of the corner to see if he can still go.
Cemetery Wind? Count out? Maybe? Judges? Yes? No? They're distracted by food? 10, 9, 8, 7, 6. Oh! They're calling them off. Just enough wiggle in there. Now, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's a knockout.
All right, so the damage Tyler had done to me when he hit me was this screw was actually bent over and embedded in the wood. We managed to get it out. But yeah, he cleaved the head of the screw right off. Oops, focus. There you go, cleaved the head of the screw right off. Garbage pile, yeah. But otherwise, yeah, we're replacing the front bit now that we have more time. And I think this is okay. I think the back bit doesn't need to be replaced yet. So that's the focus on what we're doing. All right, so this is the faceplate that was damaged mostly by Ripperoni here. As you can see, crack ran through the whole thing. It's still technically held together. Yeah, it's held together by a few fibers. It's no longer held together. So yeah, we're replacing it. It needed to be replaced. We fortunately didn't have to worry about this versus Cemetery Wind. Cemetery Wind. So it worked out. We got lucky in the brackets. And Cemetery Wind got unlucky. But yeah, we'll pop this new faceplate on, and then Homer's actually doing pretty good. My next match is against the loser of Huge versus Pipe Bomb. So either way, I plan on trying out the Giant Plow. So let's see how their match went.
Well now, that changes things a bit. Well, they got that second wheel quite good, and I don't think Pipe Bomb's getting up from that. There's the tap out. Our next fight was scheduled to be Pipe Bomb and Homer, and Pipe Bomb has to forfeit, so Homer wins.
So, Homer wins by default. It's actually a little disappointing because I did want to try this Giant Plow out, but we'll move on to the next match. And that is against none other but reigning champ Nautilus. Last year, Homer lost in 41 seconds due to antenna failure. Let's see if we can do better this time.
3, 2, 1.
Homer not wasting any time. They know Nautilus is not being business. They showed in their last one after losing, being stuck up on the wall. They're getting paid by the hour here. Nautilus chewing into that front plate and separating the front plate from the wood chassis. Homer's going to rely on those forks on the other end. And hopefully not get splintered to death.
Oh, he's tearing me to pieces!
Right now those forks on Homer doing a good job keeping Nautilus and Spinner at bay. But they're just hanging on. Big air hit from Nautilus. I got Homer hung up on him there. Hoping they can get separated. Judges have called a pause in the match to unstick the robots since they are stuck together.
I don't know, should I tap out?
I mean, what do you think the chances are?
You never know,
right?
Homer from Nautilus there is caught up on the little scoops.
3, 2, 1.
And resume. Now Homer has lost every protected piece on it other than his wood frame. Maybe sleeping up this one pretty heavily. There's the newest set of pieces.
Homer winds up high-centered on his own debris, and so I tap out.
Really close to me.
Homer has finally caved in after just getting pummeled by Nautilus. They definitely put up a good fight, though.
To the untrained eye, and maybe the trained eye as well, that match wasn't even close. But Homer actually did almost win it. When Homer ran his forks into Nautilus, he damaged a pulley, bent a motor shaft, and almost shredded the belt off entirely. Had that one engagement gone just a little bit better, Nautilus's weapon would have gone down, and Homer would have had the opportunity to just control him for the rest of the match. But you know, that's not what happened. So now let's check out Homer's damage. So this is the front of Homer. This side only has a scratch right here. Let's see, do I get that on film? Right there. Somehow we got a scratch here. Don't know how that occurred. And then we go to the back of Homer, which is where the forks were mounted, as he systematically dismantled this. And then on this side, we obviously got hit good here, but like wood did exactly what it's supposed to do. So that's good. That was a proper showing of what wood was supposed to do. And then we got nailed here. This gearbox also doesn't work as well anymore. It's gone a little crunchy. And on the bottom, we have damage here. This is when he ripped the face off. And then damage here is when he took some of the forks off. And yeah, that's it. Most of it is just the frame that's been damaged. And you know, the top and bottom plate is a little malformed, but this could be like heated up and put back into shape probably. Yeah, no screw hole mount was completely ruined. No screw hole mount was completely ruined. That got close. But like all screw holes are intact, like they can be repaired even. See here, oh wait. No, he evaporated this screw, but he did not take out the thing. I'm amazed that the front tore off, took all of the screws out, but none of the screws ripped through the body of this, and none of the screws are like left over. They all littered over the arena. And yeah, we lost a dowel, but that's just a 3/8 steel that's just cut, so it's no biggie.
Alright, no, it is just catching on the edge.
Alright, so now that we've opened Homer up, these gearboxes are loose. Oh yeah, these have taken significant damage. This was the side that got hit, so that makes sense. Yeah, this has a crack in it, but these hold well enough even when they get, oh yeah, the entire frame is starting to fail. And then, let's see here, yeah. The LEDs are probably okay. I can probably turn it on right now and find out. Do they blink? Yep, the LEDs are fine. Both of them are blinking. They just need to be put into a new bracket. All right. So that is the total of Homer's damage. Most of the things broken on Homer was just wood, or you know, 3D printed plastic stuff, PLA. Except yeah, this gearbox is a little crunchy now. So that was more significant. Shortly after this, I figured out that the gearboxes are actually always perfectly fine and have been through all of the year. The main thing that's actually failing is the motor faceplate, which I will show right here. You can see as I pop the faceplate on, there's this play back and forth because the two screw holes have actually been pulled out a little bit from the forces compared to a fresh gearbox or motor that I've just purchased. And there is no wobble whatsoever. You can't hear anything, can't see anything. So yeah, it was good that I figured out that I'm actually wrecking, you know, the $18, $19 motors and not the $60 to $70 gearboxes. On top of the frame and the motors, the forks also came out worse for wear too. Had a nice chance to get some close-up damage on the forks because I don't think I got that at Moto. So this basically would have all been done by Nautilus. So you can see here, a lot of the ends got chipped off basically when his strike either flicked them up or the time it would actually tear it off. This one is oddly bent sideways. I don't know how that happened. We definitely got some chomp there. Probably was a case that it got hit just on the edge and it just forced it away as it was trying to clear itself. Anyways, yeah, basically a lot of these are damaged to the point of needing to be like regrinded down and all that stuff, completely done fresh. Homer ends his tournament run with the top 8 position, the same as last year. I was really hoping to do better than last year, so the way to resolve this is to challenge Hyperpolarize to a grudge match. Hyperpolarized Builder gives us some zip ties to help better secure the gear motors to their brackets, which we use with the backup frame and enter the match. This is exactly the kind of matchup I've actually been waiting for with Homer. Both Hyperpolarized Builder and I think Homer is favored to win this. So let's see how it goes.
3, 2, 1.
Homer immediately against the wall, but there goes that hit that went the table into my arms. That felt not great. Oh, and we were already smoking. Stoppable force. Although, honestly, that could be a lot of things. We could have, hyperpolarized is a friction drive, and on those sudden stops, you might have just smoked the wheel itself that's driving that ring, which kind of looks like what happened. Like a burnout at the beginning of the Had that wall not been there, Zach would have been in the hospital. Waiting for a hyperpolarized, get back up to speed. Uh-oh, not the corner. You know what it is? Oh, shit. Like I said, bounce off multiple walls. The problem with a spinner is the arena can take anything you can dish out. You gotta go, ow. Guys, seriously. Alright, so anyway, what I was saying is, you are going to bring what the arena is. So these hits are right. It has to take that same force back. I don't know about you, but I can't throw a 30-pound weight like that far. Uh-oh, Homer!
Oh, yeah.
Turn!
Homer is schooled up now. Oh, we got a tap out. We now know the movable object.
So let's recap a few moments from this fight, shall we? At this moment here, I wasn't 100% sure there wasn't a breach, and that's because out of the corner of my eye I catch some debris falling here, as well as see something move right by the camera here. And it didn't help that some stuff was also flying around inside the arena. Fortunately, I quickly realized that nothing was wrong. So now let's talk about that glorious final hit. Hyperpolarized manages to fly around 16 feet across the arena as well as a few feet in the air. He first deflects off the wall before crashing into Homer. The force is so significant that the ground seems to flex downwards an entire inch before sending Homer back up. Homer manages to pop a few inches into the air, and then when he comes back down, his drive just doesn't seem to be working right. And then comes the incredible difficult decision of to tap out or not. When I hear Hyperpolarized spin up to max speed, I know for sure he's going to hit me if I give him the chance to. So, for what went through my head, for the options of letting him hit me, I'd get to see how Homer handles this kind of an impact. Hyperpolarized will deflect off Homer on the camera left direction, which will cause him to ram directly into the wall, which may hurt him. Whatever is locking up my drive may free itself, and maybe I'll still have a chance. I'll be a shoo-in for the most destroyed robot, and the crowd will love it. But as for the reasons to not, I'd likely need to order an annoyingly small amount of spare parts that'll get wrecked from this hit. I won't have to rebuild Homer for my next event in May, and I have so very little free time. I can instead allocate that bit for my 3-pounder. And most significantly, I probably won't be able to figure out why the drive locked up. So I do tap out this time, but it really did weigh on me because I really did want to know what would happen if he hit me too. But hey, maybe there'll be a next time. And with that decision done, let's go see what carnage was done to Homer. Overall, I think we just lost the just this piece of wood, and everything else actually looks okay. The drive control feels fine, the gearboxes feel fine, all that stuff. So yeah, only a little, not too bad. As you can see, that really pulled out. Like a very centered pullout, obviously, as this is forked in. Yeah. So overall, we sort of lost, I guess, just the wood and damage, because I don't think anything else took any damage from that. And let's look at the front of the shield for impacts, you know? Like, I mean, we've scuffed some bolts. But for the... Yeah, so yeah. But I think some of this is new. Like maybe the more... Like this one probably old. This one might be new. But yeah, like you really don't see that much damage to the front plate. This is held up really, really well. Like when we took the head-on hit with Nautilus last year, it left a bigger gouge in this. So yeah, the shield is definitely still usable. Alright, so the reason why there's so light damage on the front is because when he actually got us good, I mean, we obviously did hit him head-on several times, but when he tore us apart, he got us on the edge here. You can see all of the impact there. Bring it closer, my camera's probably not good enough. Oh, it's okay, that's pretty good. As Motorama packs up, I can reflect on the event and be happy with the results, even if I didn't place better this year. There were clear improvements in Homer that worked out well, like the main electronics surviving the entire event without any issue, and that fight against Hyperpolarized had some excellent hits. So I think about Homer's future and I decide a few things now. Yes, the frame will stay wood for next year, and no, there will not be a major redesign of the frame. I'd like to spend the time to have the rear wheels stick out the back for better engagements, but I'm going to be focusing on just improving his new weaknesses found this year, and maybe doing a full 2.0 version of Homer after the next moto. So Homer gets to head back home for some post-fight analysis and improvements on eliminating the flaws. To recap with Homer's damage from the previous fight. So when I got stuck in the corner, what happened is this piece of wood, which had broken off of the inside of here, basically slipped and got stuck in here. You can see the little tire burn mark on here from it being wedged in here, and that locked up this side of drive. So this side of drive I couldn't get out just because like literally it was just wedged like this. So you can see that. This cracked along here. This is a similar kind of failure that I've been getting. So with the new plan, there's going to be new side pieces that weld onto here, and then the bolt goes through here. These outside bolts will be dropped, which should reduce the stress that goes onto the wood. Plus, the side bolts will also be dropped. Or side screws will also be dropped, which will also further reduce the wood. Because what's happening a lot is that there's just so much of an opportunity for split to form. Like, you know, where this goes in, it cracks and it just zigzags along here and splits this whole area in half, which you can see right here. It's all lifted up in this area. Now, the whole thing didn't fail, but it failed enough. It's unfortunate that just this little piece jammed in the wheel there, because I definitely kept going otherwise. But, like I say, the good thing is that I figured out what went wrong, and this shouldn't go wrong in the next one. There's a chance I will still cut out this little bit of extra plastic here. Like, I like the extra side bracing that will be provided by the lid and the base by having this here. But I don't want this to happen again if it can. But I mean, this also is a freak size that it actually broke right there. I think with the fact that it's probably based on, yeah, can't get the camera in there to see really, but it's exactly lining up with where the screw went in. So if the screw wasn't there, it wouldn't have had this already split line to break this fragment off of. So I think it'll be safe to not change this plastic part here, because this piece shouldn't splinter like that again, because there'll be no voltage going on in this whole block here. There won't be one going like this. There won't be one going through here. So this wood will be a lot stronger here. So I'll still keep the dowels that go through here, and these 3 bolts will stay here. Obviously, like the fender washers, whatever, will be replaced. Yeah. So the LED mounts all broke during the tournament. They're going to be replaced with TPU, so that just doesn't happen. It doesn't matter that they flex a little bit, because they're just little mounts for LEDs. These pieces are being replaced here with a newer, beefier one. So they're going to extend all the way out, and there's going to be an end cap on here, because what happens is, which one is it? It's this one right now. Anyways, these gearboxes they get, yeah, you can see it a little bit maybe. The gearboxes are coming a little loose from the extra forces. Basically, even though this is supported like this, the amount of force that is applied is still causing these to go out. So I'm going to be basically clamping this to its gearbox mount with an extra ring piece of aluminum here. And then it'll keep the whole thing as one solid unit within this like little construct here. There'll still probably be some pivoting at the blocks right here. Another problem that happened multiple times is this mount block here, it cracks right in this corner. So the new version has a chamfer along here to help reduce that. It also only has 2 screws per side instead of 3, because the screws are not the failure point, at least not right now. So we can add more plastic, remove some screws, and that'll hopefully just make the part that's failing not be the part that's failing. We'll find out what the next piece is when it gets to it. But those are all the improvements lined up. All this turned out well. The robot mostly works as expected. Like I say, we found the main weakness is in right here, and it'll be improved. And then the secondary weakness was right here, and it'll be improved. And then yeah, these pulleys will be nylon now, which and same with these mounts are turning to nylon. They were PLA before. So these pulleys didn't crack since they became nylon. I still have to like inspect them more closely, but it just looks like that's the way to go. These are still PLA. It doesn't seem to be a problem. They rounded out a bit. Like these are a fresh set that I put on for this fight, but they did start to round out a little bit by the end of it, where like the bushings are basically bumping into the plastic. But like it being a consumable part that doesn't fail but just wears over time is fine. Especially considering it's a dead shaft that's on here, so it's not like it's too big of a concern. If anything, the wheels might wobble a tiny bit, but if it starts to wear out. But like I say, changing these wheels is super easy as it was designed, so it's not a concern. Yeah, so that covers what needs to be done or what went wrong and what needs to be done. And yeah.
So that basically wraps up this chapter in Homer's story. But before I go, I want to touch on something I discovered while making this video that kind of made me do this. What happened is I came across video of this robot right here. This here is a handmade, box frame, 2-motor, 4-wheel drive combat robot that competed in Moto about 20 years before Homer. And is also named Homer, after the same Homer. So on the odd chance someone thought my robot was referencing this, nope, this is just a crazy coincidence. So on that bombshell, I'll be concluding this video.
I hope you enjoyed. Thanks for watching.